So good afternoon everyone. Today we are going to discuss about lecture 17, that is going to be polynomial regression. Okay. So far we have assumed that the relationship between input and the output is linear, meaning a straight line, as you must have seen in the previous lecture. But in real world data, relationships are often non-linear. That means that data may follow a curve instead of a straight line. So polynomial regression helps us to handle such cases by introducing higher degree terms like x squared or x cubed. This allows the model to fit curved pattern in the data. Okay, so now let's compare linear and polynomial regression. In linear regression, the model fits a straight line to the data, but sometimes the data follows a curved pattern. In such cases, a straight line cannot capture the relationship properly. Whereas in polynomial regression, on the other hand, okay, you can see here, I'll show you. In the polynomial regression, on the other hand, fits a curve which can follow the data more closely. So whenever the data is non-linear, polynomial regression gives a better fit. Okay, see, data points are along the, you can see the, it fits the curve. Okay, so yeah, so now let's implement polynomial regression. Okay, before implementing, I think we should look into the equation part. Okay, now let's look at the equation of the polynomial regression. Unlike linear regression where we only had x, here we include higher degree terms like squared of x and cube of x and so on. These extra terms allow the model to capture curved relationship in the data. Even though it looks more complex, it is still considered a linear model because it is linear in the coefficient. So by adding these terms, we make the model more flexible and powerful. Now we'll try to understand polynomial regression using sklearn. First, we use polynomial features to convert our input into higher degree terms. For example, it automatically creates x squared or x cubed and so on. Then we apply linear regression, okay, on these transformed features. So even though we call it polynomial regression, we are still using linear regression just with modified inputs. Finally, we use the model to make the predictions. Okay. So in this script, you can see, in this image you can see, visualize the difference. The straight line represents actually the linear regression, which may not fit the data well if the relationship is curved. The curved line represents polynomial regression, which allows the data more closely. This shows why polynomial regression is useful when the relationship between the variables is not linear. Okay, however, we must be careful. Too much flexibility can lead to overfitting. Now we'll try to understand the concept of overfitting in polynomial regression. Okay, so when we use very high degree polynomials, the model tries to fit every single data point. It captures not only the real pattern but also noise in the data. This results in a very complex curve. While it may look perfect on training data, it performs poorly on new unseen data. That's called overfitting. So the goal is not to perfectly fit the data but to generalize well. Now we need to understand what is the underfitting. Okay, so we should summarize everything. Okay, underfitting happens when the model is too simple and cannot capture the pattern in the data. We have also discussed in the previous lecture about overfitting and underfitting concept. If you have not gone through it, please you can go through that. So already I have said underfitting happens when the model is too simple and it cannot capture the pattern in the data. Overfitting happens when the model is too complex and tries to fit every data point including noise. A good model lies in between. It captures the real pattern without overcomplicating. So the goal in the machine learning is to find this balance between underfitting and overfitting. Okay, you all have seen how it is there. I've discussed it. So coming to the conclusion part, in this lecture we have learned how polynomial regression help us handle nonlinear data. We also saw the increasing model complexity can lead to overfitting. So the key idea is balance, not too simple, not too complex. In the next lecture we will explore how to control model complexity using techniques like regularization, or we will move into the classification problem. So I'm grateful to all of you for coming till this part of the video. If you have really liked it, then do give your point of views. I have also attached quiz in this video so that you can watch it and learn it in a better way, and you can learn and build some projects. So I'm really grateful to you. Thank you so much. Continue to learn, continue to watch these video. Okay, thank you so much.